Good day. So now we are continuing with number 6 in the January 2020 paper. There are 40 students in a class. So we have 40 students in a class. And girls make up 60% of the class. So that means the class has both boys and girls. B for boys, G for girls. And out of the 40 girls in the class, 60%. Sorry, out of the 40 students, 60% is girls. So I just find 60%. Again, the percent sign means out of 100. So anytime you see the percent sign, just put it out of 100. That's why the sign looks like that, right? Because mathematically, I can't do nothing with this. But once I change it to a fraction, I could work out stuff now. So 60 over 100 times the 40 students. That's 60% of 40 there in maths terms. Zeros cancel out here, zeros pair off top and bottom, so I have 24 girls in the class. Now out of the 24 girls, we're splitting up the girls again into glasses and no glasses. And they said 25% of the girls in the class wear glasses, so again, I cannot use the percent sign, so I'm changing that percent to out of 100 times the amount of girls in the class. So we just find out we have 24 girls in the class, and to make my working easier, by now at this level I should know that 25 over 100 is really a quarter. So it's just a quarter of 24, which is 6. Again, knowing your tables make that stuff easier, so my answer is 6. So those were the first 6 questions on the January 2020 paper. However, they didn't cover all the topics, so what I would like to do is just go over some additional common topics that come, because the first 6 questions on the paper are going to be a mixed up computation and number theory, which is a range of topics, approximations, ratio, a whole set of other stuff you're going to see. All right, so these are just some other common questions or types of questions you're going to come across. One of them is changing decimals to fractions. Now before we get into this one, just to show you how this works, let me say 0.5 for instance. So once I have one number after the point, I put the digit back, and since it's one number, I put it out of 10. 1 with a 1 0 after it. And we already know 0.5, which is 50%, 5 out of 10. 0.5 is really a half. Same idea, if I wanted 0.25 to have 2 digits now, I'm still going to put the 2 digits over 1. Since it had 2 digits, I'm going to put a 0 for each digit. 25 over 100, which we just saw. 25 into 25, 1. 25 into 100, 4, a quarter. So here we have 0.45. So this is really 0.45 will be 45 over 100. And then I need to know my tables. What number 45 and 100 have in common? 5 from my tables. 5 into 45, 9. 5 into 100, 20. So my answer is 9 over 20. And they have different variations of it. This would have been 875 over 1000, and then I keep breaking it down, but some of them have easier ways to do it. So if I really know what these are as decimals, I could save time. So I know a quarter is 0.25. That's one of the more common ones you'll come across. A half is 0.5. 3/4 is 3 times a quarter, which is 0.75. 3/4 of a dollar. So that means by default, I know this can be 0.875, this can be 0.875. So by default, that one is the answer. And that's some methods you could use sometime, or logic and reasoning. Same idea here, you have to pay attention to what they're asking for in this one. Lowest terms mean until it can't break down anymore. So even though 12 out of 100 could break down to 6 out of 50, 6 and 50 still have a 2 that could break down into it. So the lowest terms would really be 3 out of 25. So these are 3 common questions that come changing decimals to fractions, but they could have more as well, but at least you know how to do it now. Sometimes you have HCF and LCM. HCF means highest common factor, so I want the biggest number that could go into each of these. So what number could go into 12, into 15, into 16, and you normally get it by getting the factors of them. So the factors are 12 will be 1, 2, 3, 4, 6, 12. Factors are 15, 1, 3, 5, 15, and so on. So the factors is normally be smaller than the number. Well, would be smaller than the number. So the number that could go into all of these, and again I could write it down, take a while. 1, 2, 3, 4, 6, 12. This is 1, 3, 5, 15. And 60 has plenty. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. And normally they pay off. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 1 times 15 is 15, 3 times 5 is 15. Same thing here. 1 times 60, 2 times 30, 3 times 20, 4 times 15, and so on. And you could see the highest number that all of them have in common will be 3. Same idea for this one, a little bit trickier because from your tables, you know, 9 6s are 54, 9 8s are 72, 10 9s are 90. But 9 is not the highest. It is a factor. 90 too big. Obviously 1080 too big. Because 1080 can't go into these numbers. 90 can't go into 54, 72. So it looks like 9, but it's really 18. That's why they skip out a number in between. Because this is really 9 times 6, 9 times 8, and 10 times 9. 18 3s are 54, 18 4s are 72, 18 5s are 90. So just in case this one comes up, the answer would have been B, 18. LCM is the reverse. I want the least number of plums. So once you say least number anything, that's really the LCM. And it's the same thing we do when we have fractions and trying to get that bottom number on the fractions. The least number of plums that could be shared among 6, 9, or 12 children. I want a number that 6, 9, and 12 could go into, so it will be bigger than the number for LCM. HCF will be smaller than the numbers we start off with. LCM will be bigger than the numbers we start off with. So 6, 9, or 12, I want a number that 6, 9, or 12 could go into. So instead of going through the long way, you could just try it in the answers. 6 could go into 27? No, so 27 automatically out, because the numbers have to be able to go into that. 6 could go into 36? Yes. 9 could go into 36. 12 could go into 36. 6 6s are 36. 9 4s are 36. 12 3s are 36. So 36 is my answer. Let me see why the others can't work. 6 could go into 54, 9 could go into 54, 12 can't go into 54, so he can work because he wasn't even a multiple of all three of them. And 72 could work as well, but it wasn't the lowest or the least. But you see where your table is very important. They have a next variation of the same question because they don't have a lot of these questions, so chances are is one of these two that will come if this topic comes. They use the same thing but with 6, 8, or 9 apples. And then they'll have different answers as well, and you see which one work in the same way. Then they have this one. The first three common multiples of 3, 4, and 6 are. So they want the common multiples of 3, 4, and 6, not just the first one. They want the first, second, and third one. So we need to find the LCM of 3, 4, and 6 first. So I want a number that 3, 4, and 6 could go into. So I start 3, 6, 9, 12, 15, 18. Then I do the same thing for 4, 8, 12, 16, 20, and so on. 6, 12, 18, and by then you could already see what number they have in common. All three of them have 12 in common. So the common multiple that 3, 4, and 6 have is 12. But I want the first three common multiples, meaning multiples really mean your multiplication tables. That's how I was going through my tables for each of these, by the way. 1 3 is 3, 3 2 is 6, 3 3 is 9, and so on. 1 4 is 4, 2 4 is 8, 1 6 is 6. So I want the first three terms in my 12 times table. So 1 12 is 12 will be my first term, the second term, 2 12, 3 12. So the answer for this one is going to be D.